All right, now let's take a look at the directed reading A for identifying minerals. This is chapter 1 in the book Inside the Restless Earth, and it's section 2. So it has to do with the different things we look at to identify a mineral. Remember to do all your corrections in a different color pen or pencil or marker. Number 1, what other factor besides air and water can change the color of a mineral? Impurities inside a mineral can change its color. So color isn't always the most accurate way to identify minerals because the colors can change a lot. 2 is luster. The way a surface reflects light is called luster. And what are the 3 types of mineral luster? Those would be metallic, submetallic, and nonmetallic. So metallic, it looks like metal. Non-metallic looks like a rock. It doesn't look like metal at all. It just looks like, rock. And submetallic kind of looks a little bit like metal, but not totally. The streak is the color of a mineral in powder form is called the mineral streak. And why is using a mineral streak more reliable than using color to identify a mineral? Because the streak is not affected by air or water. It's more reliable than using color. So sometimes a rock looks like gold, but when you do the streak test, you see that it's actually more of like a dark brown or a black or something. So a streak is a good way to test the actual color of a rock. Cleavage and fracture. Name 2 minerals with cleavage, a tendency to break along smooth, flat surfaces. Mica and halite. So when rocks break and they have very smooth surfaces, so mica almost looks like sheets of glass. It's so smooth, but it's a naturally occurring element. And so that's called cleavage when it breaks on these really smooth surfaces. And then the other way rocks break is fracture, where it just kind of breaks, and it's uneven, it's curved, it's irregular, it's not really breaking in any specific way. So think of if you just took a rock from your backyard and threw it down on the driveway or something and it broke into a bunch of pieces. Usually that's going to mean fracture. Hardness, a mineral's resistance to being scratched is called its D, hardness, and we use the Mohs hardness scale to determine the hardness of a mineral. The Mohs hardness scale goes from 1, which is the softest, to 10, which is the hardest. The softest is talc, which is like chalk. It's even maybe a little bit softer than chalk that we'd use on the chalkboard. It almost, when you feel it in your hand, it almost feels like soap, but it's a mineral. And then diamond is the hardest, so diamond is a 10 on the Mohs scale. Density is probably the best way to judge a mineral, but it takes a little bit of time. So the ratio of the mass of a substance to the volume of the substance is its density. And 12, what substance is usual reference point for the density of other substances? Water. And 13, the ratio of an object's density to the density of water is called its specific gravity. So density is how much stuff is packed inside a volume. So for example, a ping pong ball is about the same size and shape as a golf ball, but a golf ball has more stuff packed inside, so a golf ball is more denser. So even though they're the same size, the golf ball has a higher density. Now water's density is 1.0, and so we always think of things as either more or less dense than water. And if they're less dense than water, then they float in water. And if they're more dense than water, then they sink in water. And then special properties, like calcite and fluorite, they glow under ultraviolet light. They're fluorescent. 15, a Geiger counter can be used to detect radioactivity in a mineral. And 16, a special property of pyrrhotite is that it's a natural magnet that attracts iron. So those are some special properties. So make your corrections to this section on mineral identification. Be ready to turn that in.